Hi everyone, welcome to the first official episode of No, It's Not Just the Weather. My name is Carlota, and today, along with Alfredo and Ada, we will be covering a bit of the basics of climate change and global warming.
Yes, we basically want you to get an understanding of what is going on with our dear planet before we can dive into other issues.
So, let's start. First things first, what do we have in mind when we refer to climate change?
Well, when we talk about climate change, we are talking about long-term or permanent changes in the average conditions of the planet, emphasis on average conditions. It doesn't refer to a year being warmer or rainier than the last, but seeing changes in patterns of the data gathered during a period of time in reference to another. The fact that in your city the winter was colder than last year doesn't mean that global warming does not exist.
And fun fact, this is where the name of our podcast comes from. Climate change is not just the weather being weird, it's a much more complex and long-term process. Also, in the definition, we can include all the consequences emanating from this change in the average conditions.
So now, knowing these definitions will be very important for all our listeners, as today we often find narratives about issues of the environment and how it's changing all around, in social media, in news sources, from politicians, and more. All these definitions are sometimes inadvertently, or with certain goals in mind, confused. I am very excited to talk about these topics in other episodes, but for now, we should stay focused on establishing a clear definition of these issues from which we can start to introduce other topics.
Indeed. And this is where global warming comes into play. I just mentioned it, but it is one of the best examples of climate change. It refers to the long-term warming of the planet. And if we look at the data, according to the NASA Earth Observatory, the planet has warmed about 1.2 degrees Celsius since pre-industrial times.
Oh, but that doesn't sound like a lot at all.
I know, it may sound like it's nothing. At the end of the day, we don't notice when the weather is 1 degree hotter or colder. But when looking into the science and going deeper into the consequences, then you start to see that it is actually huge.
Yeah, and to put it into perspective, we're going to go back around 56 million years. During this time, in a span of around 2,000 years, so very, very slowly, the global temperature rose between 5 to 8 degrees Celsius, which in so many years might not seem like a lot. However, this caused the poles to lose all of their ice, and I kid you not, there were crocodiles living in Antarctica, so a few degrees can actually do a lot.
That's crazy.
I know, right?
Okay, but crocodiles aside, how has this actually happened? How have the temperatures risen so much in less than 200 years?
Well, that's pretty easy to answer because of us. Not you and me, but humans. Because of all the greenhouse gases emissions that industrialization has brought, the planet is getting warmer. These gases, mainly carbon dioxide and methane, don't let the solar energy reflected from the Earth to go back into space and leave the atmosphere, thus trapping the heat and making temperatures rise. The more greenhouse gases in the atmosphere, less heat escapes, so the planet keeps getting warmer, which then leads to another series of very serious issues.
And where do these gases come from?
So, CO2 originates mainly from burning fossil fuels to generate energy. Other industries also contribute to emissions like transportation, agriculture, etc. And also, because of deforestation, there are less and less plants and trees to absorb carbon dioxide. So, if we keep emitting more and more CO2 and we have less resources to absorb it, the levels just keep going up. And then we have methane, which comes from the decomposition of waste, agriculture, especially rice, and manure. Then we have natural sources like the wetlands all over the planet. Wetlands are places like the permafrost, mangroves, swamps, lakes, etc. Basically, anywhere where you literally have land that is wet. And the thing is, the presence of these gases in the atmosphere is natural. We need them to exist, but definitely not at this level that we're seeing right now.
Well, this sucks, right? Because ultimately, most things, or you could even say everything, depends on the climate and the temperature, right? I mean, for example, agriculture is very dependent on unstable weather patterns. If we don't have good crops, then we don't have food. Also, droughts and the sea levels will rise. That could affect entire cities. Not to mention natural disasters or people already living in terrible conditions. And this is just what I can think of at the top of my head. I can't imagine what else could be affected.
You are most definitely right. This is why we need everyone to be aware of what is happening. We won't have a livable planet if we continue at this pace.
Yeah, but not all hope is lost, right? I mean, is humanity really doomed?
Well, the thing is, we actually don't know. Because predicting these types of things can be very challenging, and there is a lot of discourse within the scientific community. The general line is that we are not completely hopeless, but no one can fully agree when we will reach the point of no return. Have you guys heard anything or read anything about tipping points?
I think so. From my understanding, they are the points or events that mark a rapid change in a system, usually from where you cannot go back. Kind of like the point of no return, as you just mentioned.
Yes, that's basically it. I am bringing them up because in the last few years, scientists have been trying to determine what are the climate tipping points. This way, we can determine the actual state of the planet.
I think I've read something about this, but the paper I read called them planetary boundaries. They described them as the processes that maintain the Earth's resilience, the planet working as it should be. It was interesting to see how complex all these processes are.
Yeah, and that's the thing. There's no one thing that can indicate us how close we are to more or less making the planet uninhabitable. We need to look at the bigger picture and how the processes interact with one another.
So, what are these tipping points? What do we know about them?
To make it a bit easier, we can divide them in three main groups: sea, ice, and land. In the sea category, we have indicators like coral reefs and oceanic currents, mainly the Atlantic Meridional Overturning Circulation, or AMOC. Then, for the ice category, we have Greenland's ice sheet and Antarctica. And finally, for land, we consider the permafrost, boreal forest, and the Amazon rainforest. These are parts of the Earth that work together to keep the planet on stable and adequate conditions for us.
Whoa, that's a lot. I know about some of them, like the ice sheets or the AMOC. That one is actually interesting. Before I learned about it, I had no idea that the sea currents had so much influence over the planet.
Okay, well, tell us about it.
Of course. First of all, we need to know that the AMOC flows through the Atlantic Ocean, having its most influence in its northern region. When the water is close to the Gulf of Mexico, it is obviously quite warm. This warmer water then flows northwards towards Greenland, cooling in the process and releasing a lot of heat to the atmosphere. That's what keeps the weather in Central and Northern Europe more bearable. Then, what happens is that when the water reaches Greenland, it is so cold and salty that it sinks right to the bottom of the ocean. And from there, it flows back south and repeats the cycle. But why are the scientists actually worried about it?
Well, because it is slightly slowing down, and it could potentially stop. This would have horrendous consequences on the weather, sea levels, agriculture, and many other things. As you mentioned, temperature and salinity are what help the AMOC to keep flowing. With the ice sheets melting, that's Greenland and Antarctica, a lot of fresh water is being poured into the ocean. Plus, global warming is also raising the average temperature of the ocean. So you can see how that's not good. But the thing is, they don't really know whether it's going to stop, if it's just going to slow down, because climate models are some very difficult things to fabricate and create, and we can make indications, and if different models based on different types of data indicate to the same thing, that's probably going to happen. However, having real specific accuracy, it's very, very difficult. But anyway, this is just one of the tipping points. And I slightly touched upon the ice sheets. I think this is what people know about the most. And apart from them rising sea levels, which is worrying by itself, we also need to consider that glaciers contain a lot of trapped gases, CO2 among them. And when they melt, they release these gases into the atmosphere, worsening global warming and entering a negative feedback loop. Less ice means more CO2, which means higher temperatures, which means less ice. And you can see how this is a problem.
Wow, this does not sound good at all. You also said something about coral reefs earlier. How do they relate to all of this?
Well, corals are dying and turning white, bleaching. Right now, according to the U.S. National Oceanic and Atmospheric Administration, an estimated 1 billion people benefit either directly or indirectly from the ecosystem services coral reefs provide.
Whoa, that's actually A lot of people.
Sadly, yes. And corals are very sensible organisms, and a slightly increase in the ocean temperature can seriously affect them. Plus, with all the extra carbon dioxide that the ocean is having to absorb, its pH levels are decreasing and the water is acidifying. According to the IPCC, 70 to 90% of coral reefs would disappear even if average temperatures remain under 1.5 degrees Celsius. And as we said earlier, we're already at 1.2.
So how do we keep the temperature from getting there? Apart from drastically reducing emissions, which is the obvious answer, what else, if there is anything else that we can do to help?
In this case, forests are some of our best allies. We need to stop deforestation. That's where the land tipping points come into play. Research done by Harvard scientists indicates that from 2007 to 2017, land ecosystems removed around a third of all emissions produced by humans. But with global warming and deforestation, these ecosystems, like boreal forest or the Amazon rainforest, are shrinking. And with the passage of time, they remove less and less CO2 from the atmosphere. And this was just an overview of the topic. I encourage everyone listening at home that if any of this caught your attention, please try to learn more about it. It can be extremely eye-opening.
For me, one of the most interesting things while learning about this was seeing how interconnected everything is. Every little detail can have an effect on so many different things. It's unbelievable how the planet can keep everything going.
Yeah, that's fascinating, but also it might be intimidating.
Yeah, fully agree on the intimidating part. And I think that's all we had to cover for today. And if any of you want to do maybe a small recap of what we covered?
Yes, sure. So some of the main ideas that I leave with today. First of all, climate change refers to changes in patterns. It's a long-term process, and it should not be confused with the weather.
Yeah, it's not just the weather.
It's not just the weather, exactly. Second of all, greenhouse gas emissions, what they are, where they come from generally, and what are the other mechanisms that are making the temperatures warmer. Then we also talked about tipping points or planetary boundaries as elements after which a small change can create a loop in which the system would then be profoundly different.
Exactly.
For all of you, the sources that we used for tipping points and planetary boundaries include points of no return. As the world warms up, these Earth systems are changing. Could further warming make them spiral out of control? By Hare, Osaka, and Stone for Girst. We also cite Earth Beyond 6 of 9 Planetary Boundaries by Richardson and other co-authors for Science Advances. And Is the Atlantic Overturning Circulation Approaching a Tipping Point by Stefan R. For Oceanography. Please follow the link in our bio for more information on this and all other sources used for this and all other episodes. And finally, final idea that I think should be quite important is that if the status quo remains regarding all this situation that we talked about, then ultimately, according to the data that we talked about, according to the science, and according to the models, then the conditions on Earth might be eventually unlivable for all of us humans.
So, our questions to you, our listeners, to ask yourselves are: do you know how global warming works? Do you know how much the temperature has risen in the last 200 years? And could you tell us some effects that the global warming has on the planet? Please let us know in the comments on our TikTok account and Instagram, which is No, It's Not Just the Weather, or send us an email at noitsnotjusttheweather@gmail.com. We're looking forward to hearing your answers and talk to you next week.